JWST is successful with this image. NASA has recently unveiled full-color images from the $11 billion James Webb Space Telescope, marking the first of what is sure to be many releases from the super-powerful optical instrument. But even taken by themselves, these 5 images mark a massive achievement and the culmination of a 26-year-long process to give humanity an even more detailed look into the early universe. In today's video, we'll be looking at some of the recently revealed stunning images from the JWST. Do these images prove that the billion-dollar JWST is a success? Stay tuned till the end to find out. We've now seen farther, deeper and more clearly into space than ever before. A stellar birthplace, a nebula surrounding a dying star, a group of closely interacting galaxies, the first spectrum of an exoplanet's light. These are some of the first images from the James Webb Space Telescope released by NASA. The revelations include a galactic cluster in a black hole, the atmosphere of a distant planet, a distant star's epic death knell, and a stellar nursery where stars are born. We've gotten a look at some of these targets before, thanks to JWST's predecessor, the Hubble Space Telescope, and all of them were known to astronomers. But due to the unprecedented sensitivity of JWST's instruments and its capacity to view objects in the infrared spectrum, we're able to see these galactic forms with more clarity than ever before. The galaxies captured in the first released image lie behind a cluster of galaxies about 4.6 billion light-years away. The mass of those closer galaxies distorts spacetime in such a way that objects behind the cluster are magnified, giving astronomers a way to peer more than 13 billion years into the early universe. The released image is of a galaxy cluster known to astronomers as SMACS 0723. It lies in the southern hemisphere sky and is 5.12 billion light-years from Earth. The detail of the thousands of individual galaxies in the image is stunning. It is like the universe in high definition. The large white galaxies in the middle of the image belong to the cluster and are similar in age to the Sun and Earth. Surrounding and interspersed among the cluster galaxies are more distant galaxies, but stretched into spectacular arcs as if seen through a magnifying glass. And that is exactly what is happening. The background galaxies are much farther from Earth but appear magnified as their light is bent toward Earth by the gravity of the much closer cluster. In the background, you can see faint red galaxies scattered like rubies across the sky. Those galaxies are even farther away. By measuring precise attributes of their light, astronomers can tell that they formed over 13 billion years ago and even determine the abundance of different elements in these early galaxies. Even with that celestial assist, other existing telescopes could never see so far. But the James Webb Space Telescope, also known as JWST, is incredibly large. At 6.5 meters across, its mirror is nearly 3 times as wide as that of the Hubble Space Telescope. It also sees in the infrared wavelengths of light where distant galaxies appear. Those features give it an edge over previous observatories. But JWST wasn't built only to peer deeper and farther back in time than ever before. The cache of first images and data showcases space scenes both near and far, glimpses of single stars and entire galaxies, and even a peek into the chemical composition of a far-off planet's atmosphere. There are over 5,000 confirmed exoplanets, or planets, which orbit a star other than our Sun, in the Milky Way alone. The existence of exoplanets raises a fundamental question: are we alone in the universe? Indeed, the explicit goal of NASA's exoplanet program is to find signs of life in the universe. Now, thanks to JWST, scientists can capture more information about these planetary bodies and hopefully learn more about whether life exists on these planets and, if so, under what conditions it can thrive. That brings us to WASP 96b, an exoplanet that's located around 1,150 light-years away. It's a large gas giant that's more than twice as small in mass as Jupiter, but is 1.2 times larger in diameter. In other words, it's puffy, as NASA put it. It also has a short orbital period around its star and is relatively uncontaminated by light emitted from nearby objects, making it a prime target for JWST's optical power. But this isn't an image of an exoplanet's atmosphere. It's an image of the exoplanet's transmission spectrum, which might be less than exciting at first glimpse. However, this spectrum, captured with the telescope's near-infrared imager and slitless spectrograph NIRISS, showed unambiguous signs of water and even evidence of clouds. NIRISS can also capture evidence of other molecules like methane and carbon dioxide. While these weren't observed in WASP 96b, they could be detectable in other exoplanets that JWST observes. JWST also took a look at a planetary nebula officially called NGC 3132, or the Southern Ring Nebula, providing scientists with more clues into the fate of stars at the end of their life cycles. NASA showed off two side-by-side images of this nebula, one taken in near-infrared light with the scope's NIR cam and a second image taken with JWST's mid-infrared instrument. In the left-hand image, which captures near-infrared light from JWST's NIR cam instrument, the phomanus traces molecular hydrogen that formed as dust expanded away from the center. The center appears blue due to hot ionized gas heated by the leftover core of the star. Rays of light escape the nebula like the sun peeking through patchy clouds. In the right-hand image, taken by the MIRI mid-infrared camera, the images also show what NASA calls shells surrounding the stars, each of which marks a period when the dimmer, dying star lost some of its mass. It's been expelling this material for thousands of years, and NASA said its three-dimensional shape is more akin to two bowls placed together at their bottoms, opening away from each other. Stephan's quintet, first observed by French astronomer Edouard Stephan in 1877, shows the strange interaction of FOD galaxies to a degree of detail never been seen before. This final image is composed of nearly 1,000 individual images and 150 million pixels, and it marks the largest image from JWST so far, representing around 1/5 of the Moon's diameter. The image is slightly misleading. The leftmost galaxy is actually far in the foreground, around 40 million light-years away from us, while the remaining 4 galaxy systems are around 290 million light-years away. These 4 galaxies are clustered so close together, relatively speaking, that they actually interact with each other. The image even reveals a supermassive black hole, located at the center of the topmost galaxy, that's roughly 24 million times the mass of the Sun. JWST is also giving us a more in-depth look at Carina Nebula, a region of the Milky Way around 7,600 light-years away. While we've looked at Carina with Hubble, the new image shows hundreds of new stars, thanks to JWST's ability to pierce through cosmic dust. The Carina Nebula reveals that the birth of stars is not a peaceful, placid affair, but one characterized by highly unstable processes that can, in some ways, be as destructive as they are generative. This image shows the cosmic cliffs, part of the enormous Carina Nebula, where many massive stars are being born. Some of the most famous Hubble Space Telescope images feature this nebula in visible light, but JWST shows it in infrared fireworks. JWST's infrared detectors can see through dust, so the nebula appears especially spangled with stars. The amber landscape that flows across the bottom of the image marks the edge of the massive, chaotic star-forming region of the nebula, so massive that the highest points in this amber band, which NASA calls the cosmic cliffs, are around 7 light-years high. Data from JWST will give scientists more information on the star formation process and may help address why certain numbers of stars form in certain regions, as well as how stars end up with the mass they have. Ultimately, these achievements are just the beginning. Scientists still have plenty of questions about exoplanets, the formation of the universe, and more, and now they have a new powerful tool in their arsenal to seek answers. So, what are your thoughts on these recently unveiled mind-blowing images? Do you think that JWST is a successful cosmic endeavor? Let us know in the comments below. That's all in today's video. Thanks for watching. Be sure to like and subscribe to our channel with all notifications enabled to never miss any exciting updates. And we'll see you in the next one.